example. This difference is not something you can perceive in real life. It's not perceptible. But if you have very precise atomic clocks, you can detect these differences. And the important thing is, one application of that is the fact that when you have GPS satellites far up in the sky, you know, like what you use to global positioning system satellites that are used to determine the positions of things and give you direction, then you have to consider the fact that that distance where they are at, the gravity pull on that affects their time. So there's usually a time lapse of about 7 minutes. So you see, with more vast distances, time is more affected by gravity. Okay, so back to our original idea. We're talking about that infinitely small singularity or density that cannot be explained by quantum theory, which is what is used by physics to explain behavior of particles at a micro level, because quantum theory does not include the concept of gravity. And now we're talking about general relativity, which is a modification of it's a modified theory of gravity, which also does not make sense at infinite quantities, because that theory of relativity is for finite quantities. But now the hypothesis is the universe began with this infinitude, in very temperature, in size, in curvature, in everything. So the equations that we're used to using to explain such phenomena are not going to work. And this singularity is called the Planck time. It's the Big Bang theory happened in epochs, in eras. So this time frame is called the Planck theory. And we're talking about really, really tiny fraction of a second. So we're talking about 1 to the power of 10 minus 43 of a second. So that's 1 second, yes, divided by 10 with 43 zeros after it. So it's a really small fraction of time. That's Planck time. Now, after that, what happened is they have this, what is called the grand unified theory. So acting on that density are 4 chief forces in physics. So you have a strong force, and I'll explain what that is. You have a weak force, you have electromagnetic force, and you have gravity. Now, ideally, science has not come up with a point where all these theories can explain what's happening at that time. So we're going to exclude gravity, because that means it's a theory of everything, and that doesn't exist. We don't have mathematical equations or an understanding that includes all those forces. So we're really talking about 3 forces here. Strong force, weak force, electromagnetic force is what is acting on that density, from which everything that you see came to be, according to the Big Bang theory. Everything, planets, stars, galaxies, plants, aqua life, everything, minerals, whatever you want, all came from that density. So now we're trying to understand what's happening through time to this density, to evolve eventually to the position where we have life. We may not get that far today, but that's the goal. So these forces are acting on that density. Now, the strong force is what binds protons and neutrons together, okay? And it acts through gluons. So you know, positive and positive tend to have a repulsion. So protons are positively charged. There's a natural repulsion. So these gluons are going to bind them together in the nucleus of an atom. So you know, all matter can be broken down to atoms. Now, within the atom is a very small center called a nucleus.